Hello students. So today we are going to learn about an ellipse. Okay. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in a plane is a constant. So ellipse has a shape like this. Okay. There are two fixed points. Okay. And we have some points here also on the ellipse. So this distance is, suppose these points are F1 and F2. Okay, this is P1, P2 and P3. So the distance is sum of the distances, that is P1 F1 plus P1 F2, that is this distance P1 F1 plus P1 F2 is equal to P2 F1 plus P2 F2 equal to P3 F1 plus P3 F2. Okay. So these distances are constant. Now the two fixed points are called a foci, that is the focus points of the ellipse. So let's learn properly about ellipse. So I have the axis. Okay. This is F1, F2. This distance, that is, this is called the major axis. Okay. And this is called a minor axis. From here to here, this distance is A. Okay. And this distance is B. So the distance of the major axis is 2 times A and minor axis is 2 times B. Okay. Now focus points are also there. So this distance is from F1 to O, that is, this is at the origin. This distance is C. Okay. So we have the length of the major axis to A, length of the minor axis to B, and the distance between the foci is given by 2C. Okay. So the semi-major axis, that is half, is A. Semi-minor axis, that is half of minor axis, is B. Okay. There is a relationship between the semi-major axis, semi-minor axis, and the distance of the focus from the center of the ellipse. And this is given by C is equal to root of E square minus B square. Okay, sometimes they give the values of C, A and B, or A and B, and you have to find C. So that time you have to use this equation. Okay, there are some special cases of an ellipse. Okay, so if you have this equation, say, so I'll write it here, or you can write it as C square equal to A square minus B square. Okay, now when C is equal to 0, we will be having A square equal to B square, correct? So the ellipse becomes circle, that is, this distance is equal to this distance. So the radius will be there. Okay, distances are same, so it becomes a circle. Okay, in the second case, when C is equal to A, that is, this C distance is equal to this distance. Okay, that is focus is at here. Okay, ellipse reduces to the line segment F1 F2 joining the two foci, that is, when C is equal to A, we have B is equal to 0. So only thing remains is the line segment. Okay. Next we have eccentricity. So this is basically the ratio, okay, of the distances from the center of the ellipse to one of the foci and to the vertices of the ellipse. Okay, and eccentricity is given by C upon A. That is, if you have an ellipse, okay, focus. So this is distance C and this is A. So ratio of these two distances is your eccentricity. Okay. Let's see standard equations of an ellipse. So there are two types of ellipse. That is, first one is our horizontal ellipse. Okay. And the second one is vertical ellipse. Okay. Here the focus points are C comma 0 and this is minus C comma 0. Okay. This is your major axis. This is our minor axis. Okay. This is horizontal. Vertical. So here major axis 2A. Here the focus points are on the y-axis. Okay, so this is 0 comma C, 0 comma minus C. Okay, this points are A comma 0, minus A comma 0, 0 comma B, 0 comma minus B. This is 0 comma B, 0 comma minus B. Okay, but in this case the major axis is x-axis. In this case the major axis is y-axis. Okay, so we write here as A and these points are B points, B comma 0 minus B comma 0. Okay, this becomes our minor axis here. So the equations are given by x square upon a square plus y square upon b square equal to 1. This is for horizontal, and vertical it is x square upon b square plus y square upon a square equal to 1. Okay, so let's solve some equations, that is questions, to find the standard equation of an ellipse. One more thing is remaining, that is latus rectum. Okay, so the latus rectum of an ellipse is a line segment perpendicular to the major axis through any of the foci whose endpoints lie on an ellipse. Okay, so this is our latus rectum. Okay, it passes through the focus and the endpoints are on the ellipse. Okay, and the given by 2b square upon a. This is the formula. Okay, let's solve an example. Find the coordinates of the foci, the vertices, the length of the major axis, minor axis, and the eccentricity and the latus rectum. Okay, and the equation of the ellipse is given by. Okay, let's write the general, that is standard form. So our A is 5 square that is 5, and b is 3 square. Okay, now a is 5, b is 3. So before deciding a and b, you have to look at the numbers. So if your a is greater, then this is horizontal. Okay, okay, and if your a is less than b, then it is vertical. So length of the major axis, we can write major axis is 2a. So 2 5 are 10. What about minor axis? 2b, that is 6. Okay, major axis, minor axis, then eccentricity. Eccentricity is c by a. So we have to find c here. C you can find by using that equation, c square equal to a square minus b square. Okay, a square minus b square. So this is 16. C is plus or minus 4. Okay, so C is 4. A is our 5. So eccentricity is 4 upon 5. Latest rectum is given by 2b square upon a. Okay, so 2 into b square. B square is 9 upon a is 5. 18 upon 5. Okay. Next question. Find the equation of the ellipse whose length of the major axis is 20. So 2a is given as 20. And the focus points are given 0, plus or minus 5. Now, these focus points are on the y-axis. Okay, so this is our vertical ellipse. Okay, so the equation is x square upon b square plus y square upon a square equal to 1. Okay, so these points are a points, 0, a. So we have a is 5. No, these are not a points, these are c points, sorry. Focus points is 0, c. C is 5. Okay, c we got, a we can find using this equation. So a is 20 by 2, so 10. A is 10, c is 5. Use that equation, c square equal to a square minus b square. So b square is 100 minus 25, 75, root of 75. Okay, so the equation of the ellipse is x square upon b square is 75, y square upon a square is 100 equal to 1. Okay, next question. Find the equation of the ellipse with the major axis along the x-axis. Major axis along the x-axis means this is horizontal. So x square upon a square, y square upon b square equal to 1. Passing through the points. Points are given 4, 3 and minus 1, 4. So we can put these points in this equation. Okay, so we'll get two equations and then we can solve them. Okay, so if I put 4, 3 here, So it will be 16 upon a square plus 9 upon b square equal to 1. And second equation is 1 upon a square plus 16 upon b square equal to 1. Okay, we have to solve these two equations. So I'll multiply here 16. Okay, so this will be 16 upon a square. I'll directly write here 16 into 16 upon b square 16. So minus minus minus. So we get here 9 minus, I'll write it here, 16 into 16 upon b square equal to 1 minus 16. Okay. So this is 16 to 56 minus 15. So b square is 247 upon 15. Okay, this is b square. What about a square? A square I'll put in the first equation, that was 16 upon 247 upon 15. So 15 I can write here. So this is 2 1 1. Okay, so a square 16 so we can cut this. We'll get 2 5s are 2 6 are 247 into 4 upon 23 a square. Here we are getting 247 upon 7. Wait, we'll put in the second equation and we'll see. Okay, second equation was 1 upon a square 16 upon b square equal to 1. Okay, so 1 upon a square, b square is over 247 upon 15. So 1 upon a square is equal to 1 minus 16 into 15 upon 247. Okay. Minus 225 plus 15. 240. It is coming 47. 7. Yeah. So a square is 247 upon 7. Okay. So the equation of the parabola, we have to write x square upon a square is 247 upon 7 plus y square upon b square is 247 upon 15 equal to 1. This is the equation.